Hello, we're Team 9B, the Data Avengers, and we are addressing the challenge presented by Baker Hughes. Our objective is to provide Baker Hughes with an analysis of the main drivers behind variance in activity durations and a machine learning model that improves the forecasting. The main constraints that we have found are due to the data being anonymized and the lack of fields available. To give an overview, for the exploratory analysis, we concentrated on the completed activities. The non-completed activities were used for the machine learning module user tests. For example, in regards to classes, 63% of the completed activities are in class 2, but as we said before, the data is anonymized, so we leave further interpretation to the Baker Hughes team. Our analysis shows that there is a substantial difference between 2018 and 2019 in the quality of the forecasting. However, some months keep the same trend, as for example, an activity that starts in September has more probability of a smaller duration variance. Looking at drivers by department, we see that Department 6 and 1 have the most activities in the data by far. However, Department 7 and 8 have the greatest average duration variances. We would recommend a further investigation by the Baker Hughes team to interpret why the two departments with the lowest number of activities actually account for the largest variances. In order to further interrogate the data, we decided to break the projects down into sizes by number of days into categories of small, medium, and large. Looking at duration delays, positive variances, by project size, we see outliers which would also need to be investigated as they will be skewing the overall averages. We also performed analysis to understand whether any of the data were closely correlated, but the correlations with the duration variance were generally weak. In order to visualize other relationships, we employed a clustering analysis. We can see that there are clusters implying inherent relationships within the data. However, we would need to discuss this further with Baker Hughes in order to make relevant interpretations based on the nature of the activities and the relevant departments, and based on a more complete data set.
All these data analysis can be explored using this interactive dashboard, which can be enabled to be able to filter by different fields or even by different classes. It also has some exploration visuals in which the user can get more insights from it.
We selected the fields which were most relevant to improve the accuracy of the model. One of the obstacles in demonstrating the accuracy of the machine learning model is that we do not have a baseline metric to compare it to. We use a decision tree to create a reliable forecasting model. Here we see that the model creates an accurate predictor of the true values for completed activities. With more data, the model will become more accurate and more valuable to the clients. We can visualize here the main driver for the model predictions. Plan duration, project duration, and project number are the most important ones. We have now a working system where the user can import activities and the model will give the predictive duration variances. This will help the planning team to de-risk the project schedule. To summarize, with the interactive dashboard containing the statistical analysis and the creation of the machine learning model, we have addressed the questions of this challenge.
So the question that has been asked is, how would you portray the confidence levels in the forecast that the model gives you, and whether the planner should override it? So we have upgraded our model to calculate and display the confidence levels and the range of the forecast. So when a planner uses this forecast, as you can see on the graph, they can see if it is suitable depending on the activity type and other human considerations and override it if needed. Further, we can build learning inside the model to capture the behavior of the planner who and when they are overriding the forecast. This will enable a more powerful system with the person and the model together. The next question that was asked to us is that we don't have the information of the successors and the predecessors of the activity. How would we use this data to improve the model, and what could be the insights? So the information of how individual activities impact other activities within the same project or even other projects could give us a lot of meaning, like the resource allocation problems, and help us become more confident in terms of the accuracy of the model. As we have explained in the presentation, this new data we can incorporate in the model, and it will help us derive the accuracy. Thank you.